So, hello everyone. Good afternoon and welcome to our today's webinar. I am delighted to have you all here with us. We have an exciting and insightful webinar here featuring one of our software engineers, Said, as the speaker. He has been involved in this project for a while. So before we begin, I just want to mention that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We'll address them during the QA part of the webinar. Without any further delay, let's dive into the program. Over to you, Said. You can continue.
Okay. Hello everyone. I'm Abu Said, software engineer at AppsCode. So today my webinar topic is effortless FerretDB replication on Kubernetes in KubeDB way. So let's see today's table of contents. So first of all, we will be discussing about what is FerretDB, then understanding the FerretDB replication architecture, then the FerretDB replication using our KubeDB. Then we will be showing a live demo, and finally there will be a Q session for you guys. So let's discuss about what is FerretDB. So FerretDB basically is an open source proxy that allows us to use MongoDB drivers and tools while storing data in a relational database. And FerretDB basically was created as an alternative to MongoDB, one that is easy to use and free from licensing restrictions. And it makes it suitable for developers and organizations that needs an open source document database with MongoDB compatible. And FerretDB is compatible with MongoDB drivers and can be used as direct replacement from MongoDB 5.0. Essentially, it converts NoSQL style MongoDB queries into SQL, and it allows us to work with structured data using familiar MongoDB style. And it also supports multiple SQL backend like Postgres or SQLite, and in near future it will bring MySQL as well. And it also gives us flexibility in storage options. After FairDB 2.0 release, it basically utilizes Microsoft newly released open source DocumentDB Postgres extension, which is significantly increase our database performance. And it is currently continuously evolving with advanced query capabilities being added regularly to support complex use case like vector search and many more. So as our today's webinar topic is mainly FairDB replication. So first let's take a look at the architecture of FairDB replication. So we'll be using Postgres backend in this in this case. So we all know that if we want to make a Postgres replica, then we have to create a Postgres replica server or pod and also a primary Postgres server. So we know that how Postgres replicated within its primary and secondary members. So it basically done by we all know that while streaming. So basically, when a CRUD operation happens in Postgres primary server, then primary server after committing the data into the primary server, it also create a wall. So basically, the wall is actually transferred to the Postgres replicas, and after that the wall will be applied to all the Postgres replicas, and this is how the Postgres gets synced with primary and secondary. And if we want to use this Postgres replica with our FairDB backend, so what we have to do basically, the architecture is more or less like this. So we have a FairDB read only, or we can say that FairDB secondary server that is actually connected with the Postgres replica or Postgres secondary server. So if a client is connected to the FairDB read only, then he basically is connected to the Postgres replica or Postgres secondary server. And also there obviously would be a FairDB primary server, which is actually for read and write operation, and which will be connected with the Postgres primary server. So if a user is connected to the FairDB primary server, he basically is mainly behind the scene connected to a Postgres primary server. We can you can take a look at the details of the FairDB replication architecture in FairDB blog. Okay, so how actually KubeDB use this replication in its own FerretDB custom resource? So basically, KubeDB is managed is Postgres backend internally. So the Postgres backend will also be managed, and the FerretDB database will also be managed. Both will be managed by our KubeDB operator. So behind the scene, what it's actually done is when a user create a FerretDB, our KubeDB operator is before creating the FerretDB, our KubeDB operator is actually create a Postgres database. So alongside with the Postgres database, our KubeDB operator will also introduce a Postgres primary service and also a Postgres standby service. So basically, what happened is when after creating the Postgres database, we KubeDB operator is actually create the FerretDB database, and along with the FerretDB database is actually create a FerretDB primary server, which actually is connected with the FerretDB's primary port, and it also create a FerretDB secondary service, which actually is for FerretDB's secondary ports. So the FerretDB primary server is basically forwarding to the Postgres primary server, and the FerretDB secondary service is actually forwarded to the Postgres standby service. So this is how the FerretDB replication works with our KubeDB. Okay, so let's see a demo. So before showing a demo, obviously KubeDB is must be installed in your Kubernetes cluster. So you can see the whole installation process in KubeDB in our KubeDB documentation. So basically, it's actually you just have to apply a Helm chart. So in that Helm chart, by default, the KubeDB operator is already installed. Already will be installed in that Helm chart. Uh, Externally, you have to set the feature gate of the FerretDB enabled. So by this, the KubeDB provisioner will provision in your cluster with FerretDB operator and also with Postgres operator. Okay, so let's see a demo. So first of all, here I am continuously watching the FerretDB Postgres pod and service in our demo namespace. We will be I will show you the demo in the in newly created demo namespace. So currently there is no resource. So first let's see the FerretDB actually FerretDB version. Okay. Okay. So before creating the FerretDB and before see the FerretDB's YAML, let's see the FerretDB version. Okay. So as you can see that currently KubeDB support 4 FerretDB version, FerretDB 1.18, 23, 24, and newly 2.0. So if you take a look at the one specific FerretDB version. Okay, so here we can see that our DB image is FerretDB 2.0 image managed by AppsCode. Also, here in the spec.postgres, basically what it does is it actually mentioning which Postgres version will be used for this FerretDB. So for FerretDB 2.0, we know that after FerretDB 2.0, FerretDB is actually used Postgres with DocumentDB extension. So we will be using the 17.4 DocumentDB extensions installed Postgres in our in this FerretDB. If a user apply this 2.0 FerretDB, and a user can also change the Postgres version if you want to use another Postgres version for its FerretDBs as backend. So he can easily change that in this spec.postgres.version YAML. We also have PG version. Yeah, here you can see if we type kubectl get Postgres version, we can see that all available Postgres version currently supported with KubeDB. So if a user want to use a specified Postgres version, then what he have to do is just change the spec.postgres.version. And also obviously after FerretDB 2.0, if a user want to use a specific Postgres version, he have to install that. He have to use a Postgres version that have DocumentDB installed. Okay, so let's see the YAML of the FerretDB. So I think so. Yeah. So basically, we are applying this FerretDB. So what is actually is what is there? So we will be using we will be create a FerretDB 2.0.0 versions FerretDB. Here spec.storage is actually used for specify the storage specification of the backend Postgres. It's not actually for FerretDB. It's for the backend Postgres created by KubeDB. It is deletion policy, and um, it actually means the what will happen when we delete when we call delete for this FerretDB. And the most important part is this server. So we here we are going to create three secondary FerretDB pod or three secondary FerretDB service server, and three primary pod or primary service for primary server for our primary FerretDB database. So the details API definition is in our API machinery repo, or what you can do is you can kubectl, you can type kubectl and explain. Yeah, in FerretDB kubectl explain, you can see the specification of here. If you type kubectl explain FerretDB.spec, you can see the all the subfield of the under the spec field. So if you want to see a server specific field, then yeah, this is the server specific field. So what is under the spec.server? So if you go into the primary, we can see that there will be two subfield. One is pod template and another is replica. So what is replica? The replica is, as I already told you, that replica is how many primary server or how many primary pod you want to deploy with this FerretDB for this FerretDB. And what is the pod template? Pod template is the pod template spec of the FerretDB primary pods. So there is so many options in the pod template if you want to configure manually. So in the under the spec, yeah, there is so many options. The details you will find the details in our API machinery documentation or our KubeDB docs. So if I want to show you a here is a here is a YAML that is actually used both two fields. So in server.primary we use replica, also you use pod template. So also as well for secondary we use replicas, and also we use FerretDB pod template. So if a user want to change, do not use the default pod template spec, then he can change it according to his need. Okay, so we will be deploying the simplest one. So we just want to deploy a FerretDB with three secondary server or three secondary pod and three secondary primary replicas. Okay, so let's apply this. Okay, so yeah, we can see that we just apply the FerretDB, and the a FerretDB custom resource is created, and so it's in provisioning state. A Postgres backend is created of version 17.4 document DB, and it's provisioning state. Yeah, and the FerretDB pod is creating. Let's wait until the both databases get ready. Then I will be explaining the every field. Yeah, our Postgres is ready. Yeah, the FerretDB is also ready. Okay. So let's see what is actually created with this FerretDB. So first of all, this is our FerretDB, and this is our Postgres. So along with the FerretDB, there is uh, three FerretDB primary pod and three FerretDB secondary pod. And along with the Postgres, which is actually our FerretDB's backend, there is by default three Postgres backend pod. And there is also a FerretDB service, which is actually FerretDB primary service, and there is a FerretDB secondary service. There is a FerretDB primary ports governing service, which is actually used if a user want to connect to a specific port of FerretDB, or if a user needs to communicate with the FerretDB ports internally. primary or secondary. So there will be a primary FerretDB governing service. Also, there will be a secondary FerretDB governing service. And along with the Postgres backend, there will be three service. One is Postgres primary service. One is Postgres standby service, which is for communicating with the standby pods, and also a Postgres primary or secondary backend governing service, which is basically for communicating internally, or which is basically if a user want to connect to a specific pod. Okay, so let's try to connect with the FerretDB primary. So first, let's see that what secret is being created with this FerretDB. Okay, so we can see that there is four secret is created. One is for FerretDB authentication. One is for Postgres authentication. Sorry, this one. One is for Postgres authentication, and those are these is basically not for this webinar. This was created in my cluster previously. Okay, and this one is actually hold the connection string of the both FerretDB primary and secondary server. So if you want to take a look at this, so view secret is actually a extension for viewing a secret. Okay, so sorry, not this one. Yeah, yeah, we can see that the FerretDB backend connection secret is actually holding the connection secret of both FerretDB primary and FerretDB secondary server, or FerretDB primary and secondary ports. So if a user want to connect to a primary, he need to use this uh, he need to use this connection string, and if a user want to connect to the secondary, he need to use this connection string. Okay, so let's see what's inside the this is the authentication secret for FerretDB. So we all know that FerretDB has no by default internal FerretDB does not have any internal authentication. It actually use the Postgres authentication. So it's actually the Postgres root users username and Postgres root user password, which is basically the FerretDB sample auth. Okay, so we want to connect to the this FerretDB primary service. So first of all, we have to port forward. Yeah, we are going to port forward the FerretDB primary service to 27017 port. Yeah, port forward is done. So now we all know that FerretDB basically use Mongoose client. So by Mongoose client, we will try to connect with the our FerretDB primary server. Yeah, I just give the password. Okay, so here you can see that I am actually inside the FerretDB primary server database. So there will be only a KubeDB system which is actually used for health check. So let's create a database. So let's insert some document under this test database. So I'm basically not inserting anything. So it will be insert just nothing, just ID. So if I use show database, yeah, you can see that a test database is just created. So what inside the test? So yeah, you can see that only there is a couple of document inside the test database. So you can see that I can read and write on this primary server. So now what we'll do is we will connect with the FerretDB secondary. Yeah, now we will again enter into the database. Yeah, the username and password will be obviously same. Yeah, we can enter the FerretDB secondary server. So if we see what's inside, yeah, you can see that the data is basically replicated. So it's actually behind the scene, it's actually replicated in the Postgres backend. And as the primary server is connected with the primary and the secondary is connected with the secondary Postgres server, so it actually showing us the replicated data of the Postgres. So if we want to see the databases inside the test, yeah, we can see that all the data we just see that on the primary server all the data is replicated also in the secondary server. Okay, so now what will happen if you want to do a write operation in the secondary server? Let's see. Okay, yeah, you can see that we can write. So basically, we can write because this is actually a secondary server. So it is actually only allow us to do the read operation. So yeah, this is almost pretty much it is. So this is actually how FerretDB is replicated in the FerretDB primary with the KubeDB in so easy way. So I think you guys can try it. The detailed documentation is in our kubedb.com documentation. So yeah, I think that's it. So yeah, if you guys have any question, you can ask.
We have a question in the chat. Can you check it, Said?
Yeah. Okay, so we have a question that what is the main difference between FerretDB 1.0 and FerretDB 2.0? So basically, FerretDB 2.0 is actually a major update for FerretDB because on the before FerretDB 2.0 update, FerretDB is not basically using the Postgres DocumentDB extension, which is powered by Microsoft. So obviously, that is a great deal for FerretDB, and which actually makes FerretDB so many faster because it actually using DocumentDB extension, which is profound. And also in FerretDB 2.0, FerretDB basically bring the replication support. So it actually a major plus after the FerretDB 2.0. So if a user want to use the FerretDB with replication support, or he want to use the FerretDB in 10x performance mode, then a user should use FerretDB 2.0 instead of FerretDB 1.0. So yeah, another question is you have mentioned that FerretDB. Basically, under the hood, the FerretDB implementation, it actually using DocumentDB extension. So, if a user want to FerretDB 2 after FerretDB 2.0, he must have to use you must have a user Postgres with DocumentDB extension, because under the in the code level, FerretDB is actually using so many DocumentDB extensions code. So it is actually a must. And what does the FerretDB play in context? Basically, DocumentDB is Microsoft managed, so it actually tested, and it is way much faster. It is basically actually is open a schema or extension for Postgres, which actually stored the data on the Postgres in NoSQL manner. Also, user can do CRUD operation on Postgres through DocumentDB. So, and as the FerretDB is basically using for NoSQL MongoDB alternative, so using the DocumentDB extension makes the FerretDB much faster and much reliable. Yeah, I think you got your answer. So if you guys have a, more question, you can ask.
Thank you, Said, for your explanation.
Yeah, thank you.
So,
Okay, so
attendees, do you guys have any further questions like about FerretDB or its replication, or maybe about KubeDB? Feel free to ask. Um, so I guess there is no question at this point. So thank you, Said, for this insightful webinar. And with this ends our today's webinar. Thank you all for your participation. Hope to see you again next time. Our webinars are actively scheduled on our website. Visit appscode.com/webinar to register. And yeah, stay connected. Have a great day. Bye bye.
yeah, thank you.